have that big a stick to wave. And when people figure it out that I actually don't have a big stick to wave, then it gets smaller.
Then it gets smaller.
Yeah. People are convinced that heads of department somehow have power or control or something. All a charade. Yeah. So people will become. Good. This noon meeting is starting at 12:10, which is my fault and I apologize. Welcome everyone and thanks for coming. There'll be a couple more people coming in. Our speaker today is Michael Cohen, who is a professor emeritus.
Yeah, well, extraordinary.
Extraordinary.
Yeah, you can see.
Yeah, clearly. At Stellenbosch University, who's worked extensively on what I would refer to, and Michael, this is probably not the right term anymore, but bibliometrics in a sense. Yeah, bibliometrics and understanding patterns of publication. And I think across all academia, although we're particularly interested in scientific publication. And this is a wonderful follow-on session to some of the things that we've been talking about as a school around patterns of publication. We had the session on paying to publish, for instance. And Michael has very kindly agreed to come and speak to us. And so, Michael, over to you. We are videotaping your session, just so you know, for posterity. But you'll have a chance to, the clicker is on the machine. It will be the mouse. Yeah. And you'll have a chance to edit. You don't have to censor what you say because you'll have a chance to check the version just to make sure. Yeah. Good. Thanks, Michael.
Okay, thank you very much for the introduction. Just to make it even better, I'm also Professor Extraordinaire at UWC, so it's squared. And basically what it means is I'm appointed through the Senate, but I'm not on the payroll. I can supervise, blah, 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 and they get the brownie points when I publish. Isn't that nice? And that's what this is all about. So my field of work is, in the broadest sense, what I call innovation policy. Some people call science policy. And I'm going to be talking about publications and how they fit in, but I'm going to situate it in a bigger picture, which is what we call our national system of innovation. That's where I want to start. And it may intrigue you to see that picture. That's my conception of what is known as the national system of innovation. It's deliberately not structured with straight lines and boxes. And for you medics, it looks a little bit like a cerebrum, which it actually is. It's a spaghetti of connections involving various players, like the universities over there, and firms, and government departments, wherever I put them in there. And they work together in a sometimes coordinated, but mostly a semi-chaotic way to achieve goals around innovation and improvement in the quality. Now, yourselves live down there, your higher education, and you're a part, and that's why this thing has a green dot there, dotted cloud. You're part of what has been called the Invisible College of Science. You link in an informal and formal way with your peers all over the world. And this larger cloud, that one out there, just indicates that the system of innovation sits inside a much more complex environment, which is both what's happening nationally and internationally. So that's the starting point. Now, we try to quantify what goes on inside this cerebrum through various measurements, one of which is to measure how much it's costing to support the research enterprise. Okay? And that's what we call a sentinel indicator, and we have a way of doing the accounting bottom-up to determine how much UCT is actually spending on research. And we get numbers, and these get aggregated up, and we do the same thing for all the universities and science councils and industry, and you get a number at the end, which is known as gross expenditure on R&D, and that's abbreviated as GERD, and we look at its ratio to GDP, and that is quoted internationally all the time. So the European Union has a goal of achieving GRT to GDP of 3%.
Sorry?
3%. Israel is the highest in the world at 4.5%, followed by Finland at 4%. Yes.
Mike, will you take questions for clarification during the talk?
As you go, yeah, go ahead.
Does that, when I think of R&D, I think of private sector R&D. I think of, but what you're talking about is not private sector.
It's everything.
It's everything. Public and private sector.
Public and private. And as things stand, roughly a quarter of South Africa's R&D is done in higher education, a quarter in the science councils, and the rest is in private sector. 25, 25, 50, it's good enough. Okay? So let the questions come as it goes, because I am assuming most of this is unfamiliar to you, particularly a brain. Okay. So back in 2001-02, our measured ratio was 0.72, and somewhere around this period here, the government announced they wanted to reach 1% by 2008, and there's 2008, we got as high as 0.89. And after that, we had a bit of a financial meltdown, and this is where we are at the moment, 0.77. So with respect, you can draw a straight line across and say it's kind of moving sideways. And we're nowhere near the desired target of 1.5%. If you look at, again, I've given you some peers abroad. Malaysia is pushing around 1%, Brazil 1.2, Argentina 0.7, Chile 0.4. So in a way, we're not doing too badly, but it's not where we want to be. So message one, you can measure, and it's going sideways. And then, of course, since we're doing an accounting exercise, one of the biggest costs is everyone in the room. It's salaries. So people matter, people do research, people get paid. It makes up between 50 and 60% of the total cost. It doesn't come for nothing. And when you then have a look at what's happening to the stock of researchers over time, then you just need to look, because this is your interest area, higher education. In 1992, we counted in full-time equivalents 3,600, and that has risen now to just around 5,000. So this is not stellar growth. And because there is also quite considerable salary inflation, well done everybody. I've been an academic, so I know what you earn. The suggestion in this data is that everything's moving sideways. And that brings me to why I'm talking to you, and that's looking at the publications. And the publications are going up. And they've gone up in whole counts by a factor of 4 in the same period of time. So something doesn't make sense.
This is South Africa.
This is South Africa.
So can I ask the previous question, were you counting salaries just that the universities are funding, not self-funded staff?
It should be everybody. They should even count me.
Okay.
They don't pay me, but I contribute to the publication output, so you should actually have an imputed value for me. And the survey, people doing the survey are not doing that, and they have extreme difficulty getting information from everybody, not just the universities. So you can compare the numbers with what gets reported to the Department of Higher Education and Training, they don't agree. It's
yes.
Everybody who's doing research.
So the previous slide that you showed, the numbers were not for self-funded staff, the FTE?
Quite possibly not.
Okay.
But it comes down to what is declared by the Research Administration Office who received the questionnaire and completed it. And whatever they tell the survey team, how can you argue with that?
Okay.
Very difficult. So good question. As with all surveys, there's a gap. So we have this counterintuitive situation. Systems moving sideways. Most of the publications come from universities, but they've gone up considerably. And not only have the publications gone up, that's the blue line, but citations have gone up, and also, and I'll come back to it later, our world share of publications has also gone up, and these are what are known as whole counts. This is all publicly available information, by the way, hence the attribution at the bottom from the National Advisory Council on Innovation. Summarizing that, our world share of whole publications has doubled. We show, if you talk about an activity measure, our activity measure is highest for the work done at UCT and KZN on infectious diseases. If you're at the international average, it would be 1, so 4.6 is very high. Immunology 2, public and environmental health 2.3, astronomy and astrophysics, and environmental science and ecology. The citation rates in these fields are also above the global average, and we are also achieving some very good things in the most highly cited journal papers. So there is robustness in our science system, despite the fact we're moving sideways. The glass is half full and half empty. Comparing UCT, WITS, and Pretoria, again, you can go to source. They're moving up pretty much in the same way. So it's not specific to one HEI or another. The activity indices for UCT, I didn't compute these, so I can't vouch for the precise way it was done, but it's broadly speaking in line with what I showed you before. And you can see that the and astrophysics people, infectious diseases, immunology are all up there. Engineering and chemistry are lagging. We're below world activity level and we're below world citation rates. So when the people in the hard science, in the engineering and chemistry say, give us lots and lots of money, you might want to ask, but what are you doing with it? Are you really doing that good science that you claim? Or they might come back and say, we don't have a critical mass anymore. We've got a critical mass in infectious diseases, we don't have it in chemistry, we're doing good stuff, we go to the conferences, but by this kind of measure, we're not making it. Now, another thing that we can look at is what is the money being on by fields. These are internationally defined fields. Let me just go to these ones here. So 96, 2016, engineering and technology, the amount spent has gone down. So are you surprised that the activity index has gone down? You shouldn't be. Health sciences has gone up phenomenally, driven by the response from essentially academia to the HIV, to the infectious diseases pandemic. Social sciences, everybody's surprised to see that's one. The size of it. When you ask a social science gathering how much do you think is spent on R&D in social science, they'll say, oh, about 5%. It's never been 5%. It's always been quite high. Turkey is much higher than 25. But this is a substantial amount of money. And also, over that period of time, flows of funds from abroad have gone up, and we know funding for infectious diseases, Wellcome Trust, DFID, and so on. That all makes sense. And another thing that we should remark on is the very high proportion going on basic research. At a similar level of development, Korea would have spent 5%. The rest was applied research and developmental research. So are we kidding ourselves? Are we spending too much on basic research? Those are political answers in the end. And then a very big amount spent in the services sector.
Michael? Sorry. Let's see you first.
So what's the 100%? Is it from basic research?
No, there's no 100% here.
Okay,
No, this has to be understood on its own, and that's a comment line, and so is that. Okay, so it's not going to add up.
So there is something else missing there as well.
Yeah.
And
The natural sciences in there.
when you say basic research, what are you referring to?
Well, it is research that adds to the stock of knowledge, and that resolves critical uncertainties, and that is not obvious when it starts out.
As opposed to applied research.
Applied. Okay. And that's tricky, because when you start interrogating for survey purposes, you need to achieve a shared understanding. That's not easy. So now I go back to the question, why is it going up? Why did the publication count go up? Why did the chicken cross the road? So here's little bits of evidence that you can think about. One is the sharp increase in NRF-rated researchers. So more money is going to clever people, and there's the trend line for you. The next one is the big increase in doctoral and postdoctoral students who are counted as researchers. That is the international norm, and what I've put in this table, if you look at, I put it underneath, there's higher education researcher headcount, not the full-time equivalent, and below that, over the same period of time, you have the, that looks wrong. That should have been increased much more. It should be 20, this should have started at about 10 and gone to 18, so I've got my numbers wrong. Message here, sorry, jump to the next previous slide and talk. Message there, the number of PhDs enrolled and the number of postdocs together has doubled. It's now pushing toward the 15,000, 18,000 mark. And that is because of additional funding that has been pushed into the system, largely by the Department of Science and Technology, the research chairs in particular, and the centers of excellence. All of that's good. There is support for research coming from government, maybe not as much from higher education as one wants, but DST, and I don't work for them, have done a lot to fill the gap. That I think is superfluous. What was I showing? Yeah, just a moment. I'll come back. Are we alone? No, we're not alone in the universe. There's the same trend for Greece, Ireland, Portugal, Brazil, and Mexico. And the dotted line I'll come back to later, just remember that's if you do fractional counting. And that's very important for this whole discussion. Okay, so now we go to fractional counting. Fractional counting means if I publish solo, the count is 1. If I publish with you, I get a half and you get a half. If I publish with someone in the Science Council, I still get a half and they get nothing. If I publish with my colleague in Kazakhstan, they get nothing, I get a half. Okay, that's how it works. So I should get a half. It's very, very difficult to do the computation of the total fractional counts. You've got to go to each article and look at the authorship. And I'll show you how messy that is in a moment. Fortunately, the United States does do at least one nice thing. And they have the National Science Foundation. This is also available to anyone who wants to go. And they do very careful compilations of fractional counts. Now, you won't be able to see it at the back. What's here is Turkey, Egypt, and South Africa. They don't publish for every country. They publish for countries which have a viable science base. And for people in the room, you will be surprised to learn that in Africa, there are 2 giants. The second giant is Egypt. And in some years, if you look at the total for Egypt, 12,000, 13,000, there we go, 13,179 in 2013, it's pretty much equal to us. So to say, we are the giant of Africa, yay, no, there are 2. After that, there's a big drop. So these are fractional counts, and when you drop down to South Africa, the total fractional count is 14,000, and with international institutions, there are fully 7,000 articles. Okay, so half of our activity involves international peers. That's good, that's great, provided what you're doing is working as genuine peers. There are countries where the international component can be as high as 80%, particularly in Africa. And that is a different phenomenon, because there, foreign researchers are coming and running around in your country, doing their own thing, going away, and occasionally inviting you to join the publication. It's a form of dependency. So over time, you would see that South Africa's international collaboration has gone from about a quarter in 2000 to 50%. So there's another thing that's going on that may account for the rise in the total publications.
Right. Is this relative to population or GDP, or is it just
No, these are absolute numbers. I haven't scaled it according to population. It's a good question, because one of the ways of presenting this kind of data is to scale it per million of population, or per research expenditure, or per GDP. And they will give you, each will give you a slightly different insight.
Because I thought Nigeria was quite high.
They are around 1/3 of our volume. They're in a bad way, actually. On most indices, they're in a very bad way. They've produced a heck of a lot of oil. So, yes, that is what we all think. So the next set, after Egypt comes Morocco, Tunisia, Kenya, Uganda. And after that, it gets very small. Then you get Ethiopia, and of course, Ethiopia is a very populous country. It's 100 million people. Egypt's what, 120 or so, also 100, and then Nigeria is close to 200. So when you scale it by population, it gets very, very small indeed. So we are, population-wise, the most productive as well, but still way below the OECD or the Europeans. Okay, now let's see. For South Africa, what are the dominant fields for international collaboration? You see physics, environmental science, chemistry, engineering, infectious disease, astronomy, starting to point toward what was there earlier, where our activity indices are very high, which was that one, and that one, and that one. So there's activity, higher activity, where we are collaborating internationally. Again, that makes sense. And now you really get down to the detail. The people at the back obviously can't see. So this is a direct screen grab from the Web of Science for the year 2016, when we were counted as 13,567 publications. And I've ranked them, you can do that automatically, according to how frequently they are cited. And what comes up, in the same year it's published, this paper has 987 citations. And somewhere in there is a South African. Now, what is this reporting on? It's the Planck 2015 satellite observatory, whose data set was released to the academic community in the year 2015. And this paper has 1,211 authors. So we can say South Africans are collaborating with researchers in 132 countries, and you will hear our politicians saying that. But it is actually nonsense. Utter nonsense. Because the chances that you even would recognize more than 2 or 3 names, and you can do this stuff. There's somebody sitting up on Upper Campus right now, online, doing this. Bing, doing some data crunching. And the rules of the game are, if you have access to the data, if you're part of the project, number one, you've got to be smart. So there's a tick for that. And you've got to be competent. And after that, the rule is, if you work on the data, you have to be named. It's automatic. So the rules of the game boost the rate of citation, and it's global, it's driven by IT and everything else. So have a look here. You get Planck, Planck, Jump, Planck, and then there is you guys, number 3 and 5. It's the Global Burden of Disease project. How many authors are in here? Well, there's at least one joker from HITS, or maybe UKZN. You're getting the point. So these are what are known as big science and mega science projects. And they are not unique, that's another takeaway, they are not unique to astrophysics. They are very much the case in medicine and many other projects. And of course, in the biological sciences, you have the famous the genome of the fruit fly. with 980 authors, including all the students who worked on it. And what is not here because of screen space, what will also be coming up here are the nuclear physics projects in Geneva, for which we should all say thank you because we got the World Wide Web out of them, which was never planned. But there too you will have a project with 1,000 authors, and the rules of the game are the same. Everybody gets cited, and even worse, you are required in the title of your paper to write text such as Atlas Detector or the Large Hadron Collider. And that is because the people behind it, the money people, want visibility for their project. So this thing is rigged to get noticed in the literature. Is this criminal activity? Probably not. It's the rules of the game. We're playing the system for advantage. And that other paper by Rusowski, terrific, the one from MRC, that was circulated to, at least to me and some others. So, fractional counting problematic. All right, at a meeting a month ago that I participated in, many research administrators were in attendance, and I asked the House, what do you do when you start claiming for journal subsidy funds from the Department of Higher Education? What do you do with one of these projects involving 1,000 people? Because the attribution to UCT would be 1 over 1,000. The answer was we don't bother. It's not worth the admin sweat to do it. Our cut-off point is around 20. If the project has more than 20 people, 20 authors, we don't bother. Because 1/20th of 100,000, 5,000 rand, it's not worth our admin time to do that. It's going to be audited, everything else. We're not going to go there. Okay, now we go to another area, which is slightly outside your immediate interest, but I want to share it with you anyway. So we are part of the BRICS: Brazil, Russia, India, China, South Africa. You, of course, probably, when you see that, say, okay, that's China who's destroying our jobs, and that's Russia who's going to give us a nuclear power plant we don't want. But there is also an agreement to engage in scientific collaboration. And one of my interests was, well, okay, in which areas? And these have been defined by the BRICS players. And now the question is, all right, so what are we actually collaborating in before this agreement? Here you will see. We are collaborating in physics and astronomy. We are not collaborating in issues of particular social importance to any of the players. Why is that? I've already shown you. It is because of the overwhelming weight that comes out of participating in Geneva and the astronomical projects. So our square kilometer array is a big science project, and it will add to this story. We are not collaborating in anything in the social sciences in any meaningful way, or any other field. It's dominated by these areas. In an attempt to try and deal with this, Nature has introduced what they're calling the weighted fractional count, which means that they are in effect adding a lower weight of 0.2 to the fractional count of astronomy and astrophysics. And one of the other takeaways for you is to ponder, well, might the same not happen in medicine? Because with these very, very large projects, you have exactly the same problem of overcounting and giving a somewhat fictitious picture of the realities of collaboration. When you do fractional counts, the picture changes quite dramatically. And instead of our world share being 0.88 or 0.9, it halves. Instead of it having doubled over the period that I've been looking at, it goes up by about a third. you could say this is a more realistic picture of what's actually happening. And then you get a very big shift in the activity. And all of a sudden, astronomy has dropped from around 3 to 0.8. Your passion has disappeared out the window. And the best we can say is we have average levels in agricultural research and psychology. So there's another takeaway. How you analyze, it's obvious, affects what you can tell. There's no one way of telling the story. You tell the story to make the politicians and the people, the funders, very happy. So stick to whole counts. It makes you look really good. But if you try to get down to the question of effort, then you've got to do fractional counts. Both of those are plagued by the problem, you don't really know who contributed what. And in some disciplines, the tradition is the first author is the one who will be cited. Doesn't matter if you're not ArtFarc, you will be cited and you're the project leader. And the last author is the co-investigator. But that is not fixed. There is no international agreement on that. There's also no way of properly attributing effort. So my parody about the person crunching data at UCT, they probably didn't contribute even one full stop in the text of the paper. They probably didn't see the damn paper where they cited. Can you call that collaboration? I don't think so.
Mark, could you just clarify a little? The earlier data you presented, the 0.8%, is based upon absolute publications or on 50% if you were 1 and 2 authors?
It is whole counts, and it means that if 5 of us in South Africa publish, it gets a count of 5. 5 authors, it's 5. If we do fractionals, the 5 would be 1.
So this is taking that into account plus an underweighting astronomy.
Yeah. So the last thing, and this probably doesn't apply here, the last thing is to think about how one goes about squeezing money out of the state through the general subsidy process, and that is that slide. And these are the claims to government to give back the, oh, I know what it is, okay, to give back the 100K or whatever it is. What that line represents, I finally remembered, sorry, I was up late. That is the increase in the amount paid per journal. It has gone up by a factor of 5, from around 20,000 to around 100,000 over the same period of time. What I've been doing in this series of slides is to throw in for you to think about possible factors that were driving this thing up. Is it the international? Is it the money from the state? Is it the increase in PhDs? I haven't run the regression yet, but I will, or somebody in the room will do it first. Because there's no one answer. Nobody's got a definitive statement. So thank you, memory, for kicking in. Staying with this one. Here, of course, you have the perverse incentive. As I already indicated to you, I don't look like it, but I'm a cash cow. I've given Stellenbosch, which is my main home, probably around 1.5 million rand, because I tend to publish solo, and I still publish quite regularly. I'm a cash cow, and there's a research account which I have access to. So that's nice, and I don't appear as a head count or a full-time equivalent, so there's a genuine undercount. And I think I'm reasonably ethical, so I don't salami slice. But there was a colleague at an unnamed science council. You do some kind of a social science survey, and out come the paper. Attitudes of one-legged brown people in the Eastern Cape. And the next month in a different journal, it'll be two-legged green people in Limpopo.
Did you say it happens at science councils?
Yes.
Yeah, there's one particular author, one science council.
You know that person, okay. And that person is celebrated because look how brilliant we are. 30 publications in a year. Wow. So that's called salami slicing, okay? And people get away with it. Because there's a perverse incentive. And then there are other perverse incentives like, well, UCT, of course, there's no perversity attached to it. You get zilch, nothing, zero, for a publication that is supported with the subsidy. Okay? At the University of Johannesburg, you get 70% of the money back, which should be taxed, I hope. At Stellenbosch, it's around 10% into a research account, which used to be the standard.
I understood that the pot of money available for publication is reasonably fixed. So, no? So our understanding was that as the publication goes, you get less and less back. Because it's a circular equation.
No. Well, it's not fixed. There's no, I'm not aware of any precept that says X% of higher education must go there. It's something that they mess around with internally, and it went as high as 120K. Now it's fallen down to about 100, and there are possible moves to abolish it completely. Because if I was looking for money to supplement student grants, student fees, that would be the first thing to go away with. Because it's around 3.5 billion rand. It's not small money. It's very important to the universities. At UCT, it doesn't make a darn difference because you don't see a cent. But there are voices saying abolish it. Because of, firstly, it's a lot of money. Secondly, there's a lot of abuse. And you have this, the last couple of slides, you have this whole issue of predatory publishing or dubious publishing. Now, I am not going to say, well, here it is. This is courtesy of Johan Mouton at the University of Stellenbosch, who looks at the claims to the Department of Education and is able to analyze which journals are being submitted for the claims and what is the number of counts per journal. And you get at the top of the list 1,617 counts, whatever period of time this was, it's about 10 years, going to, this is the top journal in the country for claims. PLOS 1 is number 2, which is respected. But number 1 is the African Journal for Physical Health, Education, Recreation and Dance. Have you ever heard of it? I haven't.
There was a story that I'll name one institution, but I'm sure it happened all over the place, that Pretoria and the agriculture faculty at Pretoria ran a whole series of journals in-house.
Yes.
And they were all subsidy bearing.
Yes.
And the people who published in those journals as single authors were faculty in the same department.
Yes.
That's the kind of thing that you're describing?
There is definitely truth in that. This one here, HTS Theologische Studies, many of these are the ones in, the ones highlighted, Mouton was saying these are dubious. Of these, I think only, well, the South African Journal of Science, and where's SAMJ? It should be somewhere. They are listed on the international databases. Most of these are not. And in support of what you were saying about house journals, yes, and so you have a company called AOSIS sitting in Durbanville that is assisting with the publication of house journals. Now, I'm not saying anything negative about AOSIS. The question that has to be looked at critically is what, and these are all recognized by the department. The department recognizes 250 South African journals for subsidy, which includes roughly 25 law journals, and there are not 25 law faculties, believe me, and 25 theology journals. Good God. And as you've observed, when you can go online and have a look at the editorial boards, and they will tend to be University of Johannesburg, House Journal. And then they'll have an international advisory board, which looks respectable. And it's a money-making venture. So there are page charges for all of these, there are subscription charges for all of them, and this company has spotted a gap in the market and has done very well. What is odd, though, is that this system was established in the 80s, during the hard years. The government of the day said to itself, we've got to keep our scientists on side. And that's when they introduced the journal subsidy, that's when they introduced the rating scheme. And the journals proliferated, both in English and Afrikaans, and there were house journals. The Journal of Ant Science, and the Journal van Beeste, or whatever it was. And in 1998, it was an investigation. And the investigation said, can them, kill them off, but retain the quality ones, SAJS, SAMJ. That was done. And as the subsidy went up, people said, wow, there's money for jam. And they proliferated again. So now it's 250, which is bigger than it ever was in the past. So here's something also. This would be killed off overnight if the journal subsidy was abolished. So the journal subsidy, as I mentioned, it's around 3.5 billion that goes from the department, from you, taxpayer, to you, the researchers, me, okay? This company enables the universities to gain anything up to 200 million rand because of the existence of these journals. So it's a very nice sort of you rub my back, I rub yours system. These guys are doing well, they're offering a service at a reasonable market rate, and everybody's happy and driving Beamers. This is our culture. But if the Minister of Education, in her infinite wisdom, takes advice, kill the journal subsidy, make no difference to UCT. But it would hit UJ very hard. It would hit these people very, very hard indeed. And that's the end. Thank you.